let's get started. So we are moving right along. Hush, children, I'm ready to teach you. All right, so we are Unit 10, Day 1. We are going to talk about solving linear systems. All right, so there are different kinds of systems. There is an independent system. And an independent system is when a system of linear equations has exactly one solution. What are linear equations? Really? What are linear equations? What do they look like when you graph them? A line. They look like lines, right? So if we're solving a system of equations, it's meaning I am graphing more than one line, so two or more, and I'm seeing what they have in common. Can two lines cross? Let's just focus on two lines. Can two lines cross in one place? Can they have one solution? Is that possible? Yeah. It says when a system of linear equations has exactly one solution. Could look something like that. So they cross in exactly one place. This is your solution where they cross. Can they have two solutions? Yeah, what would that look like? So two different lines could cross in only two places but nowhere else. Is that possible? No, I can't think of how to draw that. Yeah. Sean?
Wait, what if you like wrap the lines around the sphere?
Well, that's 3D. We're talking two-dimensionally right here.
We're talking really small.
Okay.
No, we're 2D right now, Sean.
We're 2D. All right. Can they have all solutions in common? Yeah, what would that look like? Good, two overlapping lines, exactly. That is called a dependent solution system, sorry, a dependent system. So this is a system of linear equations that has all solutions in common. And that just means two lines on top of each other. Now we can have a consistent system and a consistent system is when a system has at least one solution. What do I mean when I say at least one solution? What does that mean, at least one solution? Lexi?
They have one solution or more.
Good. At least one solution means one solution or more than one solution. But really, what are our options? Either one solution or all solutions. Those are our two options here. So it could look like this, where it's just one solution, or where the lines are overlapping. And our last new vocab word is going to be an inconsistent system. And an inconsistent system will be a system of linear equations which has no solution. What do you think that looks like?
Parallel.
Kate? Yeah? All right, Brandon.
Parallel lines.
Two parallel lines. You got it. Does anybody remember how to mark parallel, like the marking for parallel? Ange? Yeah. Arrowheads going in the same direction.
Yep.
That was geometry.
Oh, I was saying last math class.
That was the best math class.
Yeah. Because it was the easy.
I'll take it.
If you're an A. I like the fourth one.
All right. Let's do this. Number one, I want us to solve the system graphically, or solve the system by graphing. So I have 2x minus y equals 5, and negative x plus y equals negative 3. Right. Remember from Algebra 1, when you come to graph a line, you want to put it in slope-intercept form, which means you want it in y equals mx plus b. So we need to isolate the y. I'm going to do that right now. So to manipulate 2x minus y equals 5, I'm going to get y equals 2x minus 5. All I did was add over the y and then subtract the 5. And now we're going to manipulate the other one. Need to isolate the y. So y is equal to, move that x over, x minus 3. So now we have y is equal to mx plus b. In y equals mx plus b, what does the m represent? Sean?
The coefficient, like, or actually slope.
The slope. Good. M represents the slope. What does b represent? You know? The y-intercept. So here my m is 2 over 1. That is our rise over our run. And b is the y-intercept. So negative 5 is our y-intercept. Let's go ahead and graph this line. I'm going to get graph paper, but you guys could just do a makeshift graph. Okay, so here we have our y-intercept of negative 5. So remember, our horizontal axis is our x-axis, our vertical axis is our y-axis. I'm going to go down to negative 5 on my y-axis. and that is my starting point of this line. Then you're going to rise and run according to the slope. So my rise is positive 2, my run is positive 1. That means I'm going to go up 2 to the right 1, positive and positive. And then again, up 2 to the right 1. Now, because this is a system, I don't know where they're going to cross, so I'm just going to fill up as much as I can. Up 2 to the right 1, we're going to keep going. And then when I go to fill in the other side of the line, instead of going up 2 to the right 1, I'm going to go down 2, left 1. And then you connect the dots with a line and you put arrows at the ends to show that it goes on forever. Now we're going to graph the next line. The next line is y equals x minus 3. Do we all agree there is that 1 in front of that x? So my slope is 1 over 1 and my y-intercept is negative 3. So I'm going to start on my y-axis. I'm going to go down to negative 3. And then from that point, I'm going to go up 1 to the right 1. Up 1 to the right 1. Do we cross? Yes, that's all we need. Well, if we wanted to fill it in a little bit more to get a better idea, we can, but it's really not necessary. So we want our solution. Our solution is going to be the point where they cross. Let me highlight it in yellow. To negative 1. So questions for you. Is this a consistent or inconsistent system? This is consistent. There's one or more solutions. And since it's a consistent system, is it independent or dependent? Independent. Independent means there's one solution. Dependent means it's all solutions. So we're consistent, independent. Okay, you guys try this one. So you're first going to put it in slope-intercept form and then go from there.
Yeah. It's algebra.
Yeah.
Does the coefficient of y have to be 1?
Does the yeah. Mm-hmm.
Did you create the design yourself? No, you did the type of detail.
Are we ready? Yeah? Okay, let's do this. So first thing I want to do is I want to put it in slope-intercept form. So I'm going to distribute in this -3. So we have 5x minus 3y minus x equals -6. Then I'm combining my terms right here. So I have 4x minus 3y equals -6. I'm going to add the 3y over and add the 6 over. So we're going to get 3y equals 4x plus 6. Now, I need to get y by itself, so now I'm dividing everything by 3. So I get y is equal to 4/3 x plus 2. Yes?
Aren't you supposed to distribute the 3?
Oh, I lost my 3 there. Oh, that messes things up. Thanks, Ange. It messes up a little bit. All right, let's fix that. So we're going to have 2x minus 3y equals -6. So now I'll bring the 6 over, add the 3y over. So 3y equals 2x plus 6. All right, now we divide by 3. So y equals 2/3 x plus 2. No? Did I do something else?
No.
Okay, what's up?
But like, what if you had two different slopes that are like very slightly different, and the lines would just keep getting closer, and then they would connect really far out, but you can't graph it?
I wouldn't give you one of those to graph that. One of those we'd solve algebraically. Okay, so next one. So now we have 2x equals 3y plus, oh, why did I do that? Forgot to bring that 3 over. So we're going to have 3y equals 2x minus 3. Divide by 3. And we get y is equal to 2/3 x minus 1. Guys, I don't even need to graph these. Why?
That's same slope, so.
They have the same slope, so what?
So they're parallel. They're parallel, yeah.
Good. Do you guys remember if two lines have the same slope, they have to be parallel? Write this. Two lines with the same slope. What if they have the same slope and the same y-intercept?
Then they're dependent.
Then they're dependent, exactly. Two lines with the same slope, but different y-intercepts are parallel. So this is a no solution. And I'm going to say, well, you're going to tell me, is it consistent or inconsistent? Inconsistent. So we're no solution, inconsistent. All right, next one. I want us to find k if kx minus 3y equals 9 and 2x plus 3y equals 12 is a consistent system. Refresh my memory, what does it mean to be a consistent system? Brandon?
Oh, one or more. There's one or more solutions.
One or more solutions. Basically, it means that as long as they're not parallel, right? As long as they're not parallel, it will be a consistent system. So they could be the same line, they could just cross in one place. As long as it's not parallel, you will be consistent. So what I'm going to do is I'm going to put these in slope-intercept form. So we're going to have 3y equals negative 2x plus 12, divide by 3. And we have y is equal to negative 2/3 x plus 4. And then I'm going to take kx minus 3y equals 9, and I'm also going to put this in slope-intercept form. So in order to put this in slope-intercept form, I will add over the 3y and subtract the 9. So we have kx minus 9. Then we will divide everything by 3. So now we have y will equal k over 3x minus 3. So right off the bat, I know that there's no way these are the same line. How do I know this is not the same line? Antonio?
One is negative and the other one's positive.
Nope. We don't know what k is yet. We're finding k. They have different y-intercepts. They have different y-intercepts, therefore we know that this is not the same line. So now what we want to make sure is that we do not make these lines parallel. So it says find k, so it ends up being a consistent system. So our only option is for this to cross in one place. It will always cross in one place unless the lines are parallel. What makes the lines parallel? Sean?
If k is negative 2.
If the slopes are what? The same, yeah. So what makes the lines parallel if the slopes are the same? So we know k over 3 cannot equal negative 2/3. So what does that mean for us? K cannot equal negative 2. So we know k can be all values except k cannot equal negative 2. So we're good. Yes? K cannot equal negative 2. Yep. All right. So now let's just refresh our memories on how to solve a system algebraically. We're going to go through two different ways. We're going to go through substitution and elimination. Girls, can we put the phone away? Away. All right, so our first method is substitution. Let's say I have x plus 2y equals 6, and I have 4x minus 3y equals -9. What you want to do is you want to take one of the equations and you want to solve for one of the variables. It does not matter which equation you manipulate, and it does not matter which variable you solve for. But there are options that are better than others. So in this first one, it is best to solve for x in that first equation. Why? Ange? Good. It's best to choose a variable that doesn't have a coefficient that's not 1. That's our best option, because then we don't have to divide by anything. So here I'm going to solve this for x, and when I solve for x, I'm going to get -2y plus 6. Then once you solve for one of the variables, what you want to do is you want to take this value of x and you want to go into the other equation, and wherever you see x, you want to sub in -2y plus 6. So now we have 4x minus 3y equals -9. I am now going to sub in for x, -2y plus 6. Minus 3y equals -9. I'm going to simplify this as much as I can. So here we're going to have a -8y plus 24 minus 3y equals -9. We're going to combine our like terms. We have -11y plus 24 equals -9. We're going to now solve for y. So -11y equals -33. Y is equal to +3. Right, so we're looking to see the point where these two lines cross. I got my y value. What should I do now? Kaylin? Find x. So now I'm going to go back. You could really go back into any equation. It really doesn't matter which one, but I'm going to go to the one that says x equals -2y plus 6, and now I'm going to sub in the y. So now we're going to get x is equal to -6 plus 6, which is 0. Is that okay? Absolutely. So what is our solution here? The solution is x comma y, so 0, 3. Tell me, is this consistent or inconsistent? Consistent. Since it's consistent, is it dependent or independent? Independent. Okay, let's solve through elimination. So this was substitution. Let's do elimination.
Why is this one right?
Because I like elimination better. So I want us to solve 5x minus 2y equals 20 and 7x equals -4y plus 11. Okay, so what we want to do here when you solve through elimination, you want to get all the x's and y's on one side, everything that doesn't have an x and a y on the other side. So my first one, 5x minus 2y equals 20, is great. But for the second one, it's not great. I need to manipulate this just a little bit. So we're going to have 7x. I'm going to bring that 4y over. So plus 4y equals 11. So now what I want you to do is I like for you to line the two equations up. So I have 7x plus 4y equals 11. And now you ask yourself, if I were to add these two equations, will any of the variables cancel? No. So you need to make it cancel through multiplication. It doesn't matter which variable you choose to make cancel, but there's usually one that's a better choice than the other one. In this scenario, the y is the better choice. Why is the y the better choice to make cancel here? Sean?
Because you just have to multiply by 2.
Good, because you just have to multiply by 2. We have one positive and one negative already, and the numbers are smaller. 2 is a factor of 4, or 4 is a multiple of 2, so it's a lot easier than having to multiply both. So I'm going to multiply that top equation by positive 2, and we're going to get 10x minus 4y equals 20, and then we will have 7x plus 4y equals, oh, I said 20. This is 40. Nobody caught that? 10x minus 4y equals 40, not 20. And then we have 7x plus 4y equals 11. And then we add. 10x plus 7x is 17x. The 4y's cancel. And then you have 40 plus 11 is 51. Divide both sides by 17. And we get x is equal to 3. Now I need to solve for y. It does not matter which equation we go back into. I'm going to go into 5x minus 2y equals 20. So we're going to have 5 times 3 minus 2y equals 20. 15 minus 2y equals 20. Negative 2y equals negative 2y equals 5. Y is equal to negative 5/2. And I would leave it as an improper fraction. So our solution is going to be 3 comma negative 5/2. You tell me, consistent or inconsistent? Consistent, dependent or independent? Independent. All right, let's say I have negative 3x plus 2y equals 4, and 9x minus 6y equals negative 12. Is there anything I can do to that second equation to make the problem simpler? Caitlin? Yeah, we could divide it all by 3. So now we're going to get 3x minus 2y equals negative 4. Now when we go to line these two up, because I'm solving through elimination, we have negative 3x plus 2y equals 4. And then we have positive 3x minus 2y equals negative 4. And then I go to add them because I see that things can cancel. But the x's cancel, the y's cancel, and when everything cancels and there's nothing left, what number do you write? 0. And then you have 4 plus a negative 4. Isn't that another 0? Does 0 equal 0? Is that a true statement? So when all the variables cancel and you're left with two numbers and the left side equals the right side, this is going to be all real number solutions. Do you guys remember how you shortcut all real numbers? Just the R, yep, the R with the extra line. So you tell me, is this consistent or inconsistent? Consistent. Is it dependent or independent? Dependent. What does that mean? Yeah, they're infinite solutions because it's the same line. All right, I have 2 more problems to show you, and then we will be done for today. All right, right now, your instinct might be, let's eliminate these denominators. And most of the time, I usually agree with that plan of action. But I'm not going to agree with it this time because I see that I have a system. I see that my denominators are the same, which tells me I can easily cancel out. I can easily cancel out because my denominators are the same. So I'm going to go straight into stacking them. So I'm going to have 2 over R plus 3 over S is equal to 16. And then I'm going to have 1 over R minus 2 over S is equal to 1. Now, which one do you think will be easier to eliminate? The 2 over, the ones with the R's, the 2 over R and 1 over R, or the 3 over S and the negative 2 over S? Which one's the better choice to eliminate? Brandon? The R's. Because I have a 2 and a 1, they're small numbers. I only have to multiply one of the equations. So I'm going to multiply the whole bottom equation by negative 2. When I do that, I get 2 over R plus 3 over S is equal to 16. That's my top equation. Then on the bottom, I get a negative 2 over R plus 4 over S equals negative 2. Are we all still good? Now what we want to do is we want to add these 2 equations. When I add these 2 equations, the 2 over R and the negative 2 over R cancels. What's 3 over S plus 4 over S? 7 over S equals 16 minus 2, which is 14. We still need to solve for S, but we know how to solve this. What I'm going to do is treat this like a proportion. I'm going to cross multiply, and I'm going to get 14S is equal to 7. Divide by 14 on both sides, and I get S is equal to a half. I'm not done. What do I have to do now? Sub back in to find R. This is going to be the part that takes a little bit more algebra skills. So I'm going to go back into one of my equations. It really doesn't matter which one. Let's go back into, I don't know, 2 over R. What was it? I solved for S. We'll do the 1 over R minus 2 over S equals 1. So I have 1 over R minus 2 over a half equals 1. Can I simplify this 2 over a half? Yeah, isn't this the same as saying 2 divided by a half? Keep, change, flip. So what does that whole thing become? 4. So we have 1 over r minus 4 equals 1. I'm going to add that 4 over. 1 over r equals 5. Cross multiply. We get 5r equals 1. R is equal to 1/5. And that's our solution. Do you guys want to try one on your own? Here, try one of these on your own. I will tell you, you're going to get fractions for both of these answers. Okay, the bell's going to ring in a couple of minutes. I'm going to give you guys the answer, and then if you guys want, you could remind me, and we could go over it next class. Oh, sorry, it's not a point. Wrong answer.